In the next problem, we have tangent, arctangent of a sum. So let's go to our tangent formula. Let's see, if I had tangent of alpha plus or minus beta, or if this case, if you want to just focus on plus because we have a plus sign in there, we can maybe just do that this time, is tangent of the first plus tangent of the second over 1 opposite, so minus tangent of the first times tangent of the second. Okay, so we're going to use that, where arctan 2x is the first and 3 pi over 4 is the second. So tangent of the first plus tangent of the second divided by 1 minus tangent of the first times tangent of the second. Okay, let's keep cleaning this up. Tangent, arctangent goes away. They can't reduce each other or cancel each other out, and we just get 2x. Okay, the ratio of y to x is at 3 pi over 4. Well, there, the y value is the square root of 2 over 2. The x value is a negative square root of 2 over 2. So since they're identical, we get 1, but it's going to be negative 1 because x values are negative, y values are positive. 1 minus tangent, arctangent goes away. So 2x times, again, negative 1. Okay, so we have 2x minus 1 in the top, and we have 1 plus 2x in the bottom. Okay, and that's pretty much, since we don't have fractions inside of fractions, and there's no square roots radicals, we can call that one done. Okay, now, normally we go up to the part that had the inverse and we put it between negative 1 and 1. But that's only when you have arc cosine and arc sine. With arctangent, here, let's go back up to the original part of the problem, or where all my notes were. With arctangent, that theta, we don't have any restrictions. It doesn't have to be between negative 1 and 1. It can be for anything. Okay, so we don't really have to worry about sandwiching our angle there. And remember, that's because in the original tangent functions, if we're going to graph them, it goes from here to here. That's the original tangent. And look, the range here is all real numbers. It's forever down to forever up. And the range in the original function is the domain of the inverse function. So the domain here is then therefore all real numbers. Okay, so really, kind of coming back down, we don't have to exclude anything, or we don't have to worry about sandwiching 2x in between anything. We just have to pay attention to the original function and go, okay, is there anything value of x that's going to make that denominator go to 0? Well, let's see, 1 plus 2x. I don't want that denominator to equal 0. So if I move 1 over, it's saying 2x cannot equal negative 1, or x cannot equal negative 1/2. So right there, because if I plug in negative 1/2 right there, 2 times negative 1/2 is negative 1. Negative 1 plus 1 is 0, and I would be dividing by 0, and that doesn't work out. So we actually have to include that as our answer. Okay? If there wasn't a variable in the denominator, then I wouldn't have to have worried about anything, but in this case I did. So here's E. The difference with E from what we're used to seeing before is this 2 sitting right there. Okay? It's normally we see just sine arc cosine, or cosine arc cosine. Now I have a 2 in front. Well, do you remember a formula that says what to do when your angle is like sine of 2, let's say theta? Well, that opens up to 2 sine theta cosine theta. In this case, our theta is all of that right there. So sine of 2 theta, and we need to break that up. So it's going to be 2 sine of theta times cosine of theta. And if you're wondering if this lesson summarizes pretty much everything you know about trig, I would say yes, probably so. Okay, so 2 times sine arc cosine, they don't match up, so I have to do the square root of 1 minus that angle squared. Here, cosine arc cosine match up, so now times x over 2. So if we want to put them even in parentheses, here's 2 times this times this. Okay, why don't we group the first and third? What's 2 times a half? Well, it's 1. So I can just say x. And here in the square root, I've got 1 minus x squared over 4. So let's keep cleaning this up. So 4 over 4 will give you 4 minus x squared over 4, just combining those two terms into one fraction. So x, whoops, not equals, but x times, and let's divide up that radical to 4 minus x squared over the square root of 4, which is 2. And if I want to, I can write like x over 1 times that. So if you kind of want to write it maybe as x over 2, I don't know, times then the 4 minus x squared, it's really up to you. It doesn't matter. It's just more I want you to realize that everywhere you see a variable, that's always in the numerators. And the only thing that we really have in denominators is just the number 2. So I can box that up. And then when I go to my stipulations, I really don't have anything to worry about as far as excluding. Okay. Go to the original problem. The inverse part is a cosine, arc cosine. So that tells me that I need to take that angle x over 2 and put it between -1 and 1, which is the same thing as saying -2 is less than or equal to x, which is less than or equal to 2. Box that up and we're done because, like I said, there's no variable in the denominator, so nothing that we have to worry about. Okay, part F. Part F, again, just like the one right above this, the only unique thing that we have here is the fact that we have a 1/2 sitting where we normally don't see it. Because the rules only say sine of arc cosine or cosine arc cosine, those things. We're not used to seeing a number in there. So if we see something else in there, what we've got to use is another identity to help kind of open it up so we can use our identities from this lesson. Okay, sine of 1/2 theta, or sine of theta over 2. If I want to increase that, if I want to double that angle, remember it is the square root of 1 minus cosine of double that angle, which is theta, over 2. Okay, well in this case our theta is all of arc cosine 2x. Alright, so our formula tells us that's going to be the square root of 1 minus cosine of all of that angle, so arc cosine of 2x divided by 2. Okay, well at least the cosine arc cosine matches up. That made it nice there. So 1 minus 2x over 2. And from there, let's break up the radical to focus on the top and then focus on the bottom. So rationalizing it out, we'll put it as the square root of 2 of the square root of 2. And we get, we can write this as 2 times 1 minus 2x all over 2. Okay, I can't cancel those 2's because one's inside of a radical and the other one's in the denominator. But at least we can kind of look at it that way. Or if you wanted to go ahead and multiply 2 times 1 minus 2x and write it as 2 minus 4x all over 2, either one of these is perfectly fine with me. Okay, going back to our original problem, we realize it's an arc cosine, so I've got to take that angle of 2x and put it between -1 and 1, and that's saying that x has to be between a -1/2 and a +1/2. My denominators in both cases are just 2, so there's no way that's going to be an x. And I'm going to plug in 1/2 here in the radical just to make sure I can take the square root of it. So 1/2 of 4 is 2, and 2 minus 2 is 0. I can take the square root of 0, so that is good. That checks off. Either one of those would be perfectly fine with me. Okay, moving on to example 3. Example 3 is kind of a summary of this whole lesson so far, in the sense that we're going to use all of our properties of arc cosine and arc sine and arc tangent, and we're going to want to solve equations with it. But just in those last prior examples where we had to really focus on when our function would work and what intervals they would work, that's what we're going to use to help check our answers, to make sure we get the correct answers. Okay. Well, over here on the left side of this equation, it says sine arc cosine. There's nothing sitting there in front of that, so I don't have to use any special formula. I can just use the formulas that we have at the beginning of this lesson. where sine arc cosine is the square root of 1 minus our angle squared. It's going to equal 15x. Okay, so the square root of 1 minus 64x squared is equal to 15x. And this is from here, it's just typical algebra. We want to get rid of a square root, so let's square both sides. And 1 minus 64x squared is equal to 15 squared, which is 225x squared. So I've got 64x squared and 225x squared. So let me move that over. We'll see if we can finish this out. So 64 plus 225 is 289x squared. I'm just going to isolate this x squared. So let's divide both sides by 289. So 1 over 289 is equal to x squared. And we're going to take a square root with a plus or minus. So the square root of 289 is, and the square root of 1 is 1, and the square root of 289 is 17. And we'll get that to be x. Okay, so that's what we're intending our potential answers to be. But we have to double check we need to make sure we have this whole area that we've been doing before of being able to check our answers. And one of the easiest ways to check them, first of all, is you can go up there, and since I have an arc cosine, I know that 8x needs to be between negative 1 and 1, or it's saying negative 1/8, or x is between negative 1/8 and positive 1/8. Okay, well 1/17 is definitely smaller, so the positive and negative form would definitely fit in there. But it doesn't hurt to take each time is to go ahead and take 1/17 and plug it into your calculator. So what you would do technically is go to your calculator, make sure it's in radian modes, and then what I would do, modes, I should say mode, is let's say we want to do the positive one. So 8 times 1/17 is 8/17. So in your calculator I'd go, okay, 8 divided by 17, get that decimal, and then hit second cosine, so you get the cosine inverse, and then from there you would hit sine. And like for example, I just did it just right now, and it comes out to be 0.88823, yada yada yada. And I would go on the right side and see, okay, what's 15 times 1/17? So if I go 15 times 1/17 or divided by 17, I get the exact same thing. So I know the positive checks out, but do the exact same thing for the negative. So again, I'm going to go 8 divided by 17, make sure it's negative, get that decimal, hit your second cosine, and then hit sine. And again, it comes out positive, a 0.88823, okay? But if I plug in negative 1/17 on the right, what's 15 times negative 1/17? It's obviously going to be negative. So what that's telling me is the negative 1 actually doesn't work. So even though it fits in our interval, it doesn't work because it's always good to go back and check your answers inside. So really my answer is only the positive 1/17. Okay?